Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running nationally syndicated radio talk show on computers and technology and blurry cameras. Everyone, welcome into the program. I hope that you're doing well. And for whatever reason, that's not working quite right. But everyone, we'll work on that. But everyone, welcome into the program. I hope that you're doing well. And obviously, as Ralph and I were talking before the show, a lot of news happening this week. But hey, that's okay. There's still time and a place for other news. And boy, does Ralph have other news for you. We have 4 great stories, everything from space to science, just stuff that you probably haven't heard of and you definitely should. So joining us here in just a moment will be Ralph Bond. And man, does this camera annoying me. But anyways, everyone, computeramerica.com. That's where you'll find everything, including past shows, future shows, podcasts, of course, any contest giveaways. The recording show notes is going to be a huge thing. All that and more. So everyone check that out, computeramerica.com. Let's see. So with that being said, we'll also have a link in the show notes today to Ralph's site. So if you want a more Ralph-focused, list of shows, his website is the perfect place for that. So with that being said, everyone, computeramerica.com, and why don't we go ahead and just get things started? So joining us today is once again the Science and Technology Trends correspondent for Computer America, and of course also the Tech Insider for the Mark Mason Show, KEX Portland, Oregon. Ralph, welcome back onto the program. How you doing?
Hey, it's great to be back, Ben, and you can work on focusing your camera while I set the stage for us if you need some time.
Yeah,
so it's great to.
Didn't even have to do a thing. It just started working.
Oh, there
it
you
works
go.
when it wants to.
Oh, good.
So.
Well, see, there you go. It was afraid.
Yeah, exactly.
So,
it kept seeing my hand come towards it, and it was getting more aggressive. Yeah,
yeah, that's like talk to the hand, right?
Exactly. So, Ralph, how you doing?
Doing great. It's great to be back. And this week we have, as you alluded, 2 space-related stories, and then followed by 2 really, for me, very interesting medical tech news items to share. So we've got a good lineup today.
Perfect. And I'm looking forward to it. So for the new listeners out there, why don't you go ahead and tell the folks what your mission is here on the show every week?
Yeah. And welcome, new listeners. I'm an aggregator of science and tech news features I find by monitoring a host of online news outlets. I just kind of scour them every day. I look for important, and sometimes these stories, they're important, they're very serious, but sometimes they're kind of on the wacky edge too. So it just depends. But all of them, generally speaking, don't capture mainstream press attention. And Ben and I were talking about the passing of Queen Elizabeth. Mm-hmm. The news cycle is so inundated with so many stories that a lot of this news that's very significant in some cases just flies under the radar for understandable reasons. So those are the kinds of stories that I try to bring up to the surface. And I'm always on the lookout for news that gives a glimpse into where we're headed in robotics, medical technology, sustainable energy technology, transportation advances, space research, physics, you name it. And what I do, and Ben and I together do, is take each news item and present the essential points, just the highlights, in a very, we hope, digestible human form. And I stress to our audience to check out, as Ben mentioned in passing at the beginning here, the show notes that we put together, because they contain posts to the links for the articles, images, and so forth. So if you want to dive deeper into the science that we're only going to highlight, you can do so through the show notes. So please come out to computeramerica.com, get those show notes.
Right. And yep, they'll be up by the time everyone is able to listen to this. So let's go ahead and just go right into story number 1. And this has to do with, a common topic, and talk about dominating the news cycle. Past week or two, it's, heat wave this, heavy rain, torrential rains that. It's, climate change. And I know here in the U.S., you really don't hear that much about it, but like the horrible flooding going on in northern Pakistan. Some of the worst they've ever seen.
Yep.
Climate change is, really getting a lot of attention, but how to fix it, that seems to be going by the wayside. So story number one, fix it. And to fix it, you need to measure it. And story number one, Ralph.
Yeah. And Ben, your point about climate change is so well made. I feel like 2022 has been the year the hammer of climate change has really bonked us all on the head and help awaken us.
It's a little tiring, Ralph, that it's like it seems like every other day, every other week, it's highest record or, driest, wettest, longest, hottest, all those kinds of things every other week.
Yeah. And talking about floods and that sort of thing in the West here, and especially the Northwest, forest fires. Northern California up has been just a terrible thing and attributed again in part to climate change. But let's get into the first story. Sure. You'll see how it all relates, everybody. So the headline here is new satellite will track the ability of our planet's forests to fight global warming. Got this story from Popular Science. It's pretty darn interesting, at least to me anyway, especially being up in an area in Oregon with so many forests. Okay, so first let's set the stage for this story. In 1 year, a single mature tree can absorb more than 48 pounds of carbon dioxide from the atmosphere and release oxygen in return. I think we're all familiar with the process of photosynthesis. And that little data point came from the Arbor Day Foundation. But in total, our planet's forests absorb about 8 billion tons of carbon dioxide from the atmosphere each year. So, monitoring the condition of the Earth's forests is critical in our fight against global warming. So with this in mind, Ben, sometime in the second half of next year, the European Space Agency will send a radar reflector satellite about 39 feet in diameter into orbit to measure and monitor the state of our world's forests. And as part of the agency's Biomass mission project, the radar reflector satellite will have the ability to look through even the dense leafy canopy of tropical forests to determine the amount of woody biomass beneath. And it will do this by making multiple passes over the Earth using a special radar wavelength that can penetrate the leafy canopy of any forest. And of course, the tropical forest, this is a big challenge, but it can do it. And the radar reflector apparatus will look through the leafy canopy of tropical forests to weigh out the woody biomass beneath, as we mentioned, taking multiple passes. But it's going to use the P as in Paul, P-band frequency to mark changes in biomass over time. And this band, the P-band, is a special radar wavelength about 70 centimeters that can penetrate the leafy canopy. So that's a little bit of the technology behind its ability to see through and get an estimate of the woody mass below the canopy. So the Biomass Mission project, which is pretty fascinating, it's a worldwide effort involving 10 countries. Pretty neat collaboration. And it plans to map the world's trees to document and chart changes due to natural events such as forest fires, which is very germane to the West these days, and human factors, again, germane to my part of the world, such as logging, that impact the ability of our planet's forests to capture carbon dioxide. So it's going to be kind of like a monitoring system as clear cutting and other things are going on in the world that are, unfortunately taking away a lot of the ability of our trees to help us. So there you go.
Yeah, and like I said, the ability to measure something is the first step to fixing something. You don't really know if it's a problem. Ralph, I think everyone can say that, logging, clear cutting, destruction of mature rainforest, like that's obviously a problem. But how big of a problem? What do we need to focus on? This is certainly something, very different. And Ralph, you introduced something new, and I was going through reading some science journal about it. So P-band and, being able to just using the sensing ability of these satellites. I mean, I guess they call them pulsar. So not pulsar, like the star and that kind of thing, but pulsar, PALSAR, is using the P-band and being able to measure that, which is different than what I thought was LiDAR. But thank you for introducing a new version of kind of sensing technology. So pulsar has been added to my vocabulary.
Hey, good.
Perfect. So story number one, and looking forward to seeing, getting a sense of how do we fix it? That's huge. So story number one, very important. Story number two, though, also with satellites and NASA, but they're looking at how to save more than just trees and planets and things. Well, actually, no. They're looking to save the planet. That is really what they're after. So story number 2.
Yeah, story number 2. And before I give you the headline, have you seen the film, the Leonardo DiCaprio movie on Netflix called Don't Look Up? Have you seen that?
I have not, but everyone is talking about it. I need to.
It's a fun. The topic is terrifying. It's the premise of the story. No surprises. There's gigantic.
Jordan Key, Keegan Michael Key, Jordan Peele. Jordan Peele was the director of that one, right? I believe.
Think so. I think that's right. And it's of course, it's one of these doomsday movies where a gigantic asteroid's coming to Earth, and the scientists in Japan and in the United States are aware of this and trying to get our respective governments around the world to wake up and get ready for this thing. And nobody wants to hear this bad news. And so it's
sounds
a fun,
all too accurate.
Yeah. When of course, I guess let's be fair. If there's an asteroid coming toward us that cannot be deflected, nothing you can do about it, and it's going to guarantee to destroy the world. Well, it would be hard to swallow that pill, to say the least, but I digress. Sure. So here's the headline. NASA is about to test deflecting an asteroid. And I got this first from futurism.com and then picked it up a little bit more with an outfit called earthsky.org, which is a fun outlet as well. And many other people covered this story too. But coming up, this is timely, coming up on September 26th, NASA's Double Asteroid Redirect Test spacecraft, or DART for short, will collide with a small asteroid called Didymos B, which is about 16 million miles from Earth. Now, launched late last year, DART is NASA's first planetary defense test mission, the first, and will be the first real demonstration of our potential, I would say, ability to defend the Earth from an asteroid on a collision course with our world. So that's the purpose of this big experiment. And Didymos B, also known as Dimorphos, is a tiny little moonlet, only 525 feet in diameter, that orbits its much larger namesake, the Didymos asteroid. Hence the B is in boy for the little guy that orbits this larger asteroid.
Yeah. And of course sounds small, but 500 and some odd, that's, actually just about 2 football field lengths, that's a big honking rock. You don't want that thing hitting your planet.
Well, that's a fair point. And it doesn't take a big, something that big could be devastating to our planet. Yeah, good point. So if all goes to plan, the DART spacecraft will collide with the tiny moonlet at 15,000 miles per hour. And NASA hopes that the nudge from DART's impact will push it slightly from its regular orbit, simulating deflecting the path of an oncoming asteroid. Of course, that's the idea. And according to a NASA announcement about this project, the test will show that a spacecraft can autonomously, that's a key point there, autonomously navigate to a target asteroid and intentionally collide with it to change the asteroid's motion in a way that can be measured using ground-based telescopes. And DART will provide important data to help better prepare for an asteroid that might pose an impact hazard to Earth should one ever be discovered. Keep your fingers crossed. Don't look up.
Yeah, and that has a lot to kind of do with it because we think about this and we hope that we see him coming, but Ralph, I mean, how many times do we just kind of hear about these things? It's like, and NASA's like, in about 3 months, this thing's going to be between the moon and our Earth, which is still a decent amount of distance, but too close for comfort. So
too close for comfort is right. No kidding. Jeez.
This is very, very cool. And Ralph, unfortunately, unlike the movies where it's not, what was the one where they sent the astronauts and miners? And
was that Armageddon?
Was it Armageddon or something like that? But yeah, they send the asteroid and, action movie sequences commence and they were planted a nuke on it. This seems more plausible. So good job on NASA.
Well, this is sort of, you could think of it like a shooting pool. Right. So you send the cue ball down there and just sort of knock this guy out of the way.
Well, yeah. If the pool ball was, what 10,000, 15,000 times the mass of your cue ball, then yeah, absolutely, it's very really incredible that they can even calculate that. So good on them.
Yes.
Story number 3, though. Let's talk about a little bit of medical science. And I know that you're a big fan of this, and obviously you've been through a number of major surgeries yourself, and the ability for doctors to collect data, be it non-intrusive, reduce the amount of in time for the patients. Like there's, honestly, Ralph, like I was just in the hospital the other week with my mother, and it's all like almost everything's outpatient. Almost everything is outpatient.
Yeah.
It's incredible how far we've already come, but we're getting better. So story number 3.
Yeah, this is really interesting. And once again, drum roll, please. MIT. I know we do a lot of stories about MIT, but what an amazing bunch of folks. Anyway, so the headline here is MIT, of course, Massachusetts Institute of Technology. Engineers have created stamp size stickers, a little bit bigger than our stamps, that can see inside the body. And I got this from businessinsider.com. That was the first article I saw. And then I saw other articles too. And you can see the image in the show notes showing the scale of this thing on somebody's arm as the doctor is applying it. Anyway, engineers from MIT have created a Band-Aid-like adhesive stamp size sticker that can provide live high-resolution ultrasound imaging of blood vessels and internal organs when worn by patients. Oh, yeah. This is great. The wearable medical device can provide continuous ultrasound imaging of internal organs for up to 48 hours. From a diagnostic point of view, that 2 days is a good run of time. The stickers, measuring 2 by 3 centimeters, so they're bigger than our postal stamps, adhere directly to the skin and could support diagnostic and monitoring tools. So that's key, both diagnostic and monitoring tools for various diseases, for example, heart conditions, pregnancy-related complications, and several types of cancer. The research team sees a future where doctors would have a box of stickers, each designed to image a different location on the body so they can be tuned. I mean, it's just the depth of this is the profound possibilities of this development, I think, are just overwhelming. I'm speechless. Right. Anyway, while the experimental devices today, these little stickers today, currently need to be wired to transducers to produce clear images, so they're confined right now to the lab or to a facility, the MIT engineers are working on creating wireless versions. That's the next step that would allow doctors to monitor patients wearing the stickers after they leave the hospital or doctor's office. And just as you alluded to some of the litany of surgical things I've gone through, I went through open heart surgery in 2011, and then about a year later, they had to put 5 stents into me. Well, wouldn't it have been great if the cardiologist team and my doctors could have said, Ralph, we're going to put one of these little stickers over your heart area, and we're just going to periodically take an ultrasound peek and see what's going on. And imagine if they could do this remotely. I have no idea they're even doing it.
Much more amazing? Peace of mind instead of just crossing your fingers.
Gosh,
and
yes.
Yeah, hopefully there's no leak. Now you'll know.
Well, yeah, precisely right. Yeah, because when you do the vein replacement, artery replacements in an open heart surgery thing, they definitely want to make sure the plumbing is all holding well together.
Yes.
So for me, they mentioned the use for heart conditions. How fantastic that would be for a recovering patient, and even for ongoing. Maybe you come in twice a year and they say, Ralph, we're going to put a sticker here on, and we're just going to, watch you for a couple of days. And okay, everything's great. Come on back, return the sticker or whatever they do with these things. Maybe they can be recycled. I don't know. But I just loved this story. I just thought this was such a neat thing. And boy, if you want to have a reason to feel good instead of bad, which is what news usually does for us these days, check out medical technology news. It's very uplifting.
Right. And, I could even, and part of it seems like they're aiming for, someone's in the hospital, they're laying in the bed, they put one of these things on, like you said, the heart, the stomach, the lungs, whatever it may be.
Sure.
And instead of having to wheel in that machine and, trying to get information on demand, they can just kind of hook up to it and get continuous feed for, up to 48 hours. Just information, immediacy, and just being able to respond to these things. Time is of the essence when it comes to medicine. It's, this is a huge advancement, and I'm looking forward to, like you said, the wireless version. Right now they said wired,
yes.
Very, very
That's
impressive.
the answer.
So,
hey, you know what, Ben? I just thought of something, Ben. What if you married this? So you have a wireless version of this. Let's say it's a pregnancy situation, and maybe there is a potential complication with the pregnancy. The woman wears the patch, and what if the ultrasounds are periodically taken, but AI-based systems remotely are able to see, oops, that's an anomaly, ding, 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 and alert the medical staff. So it wouldn't have to always be a human being being dedicated to periodically. What if you married this? I just thought of this. If you married it up with AI. Wow.
One of my first thoughts as well, and I wasn't going to, kind of kludgy everyone's brain up with it, but I immediately think of Google's AI that is trained, to detect eye cancer and glaucoma, where, they processed 1 million images that they got in certain ways from New York City. But anyways, they processed 1 million images, and they're able to, with like 95% effectiveness, detect glaucoma in patients just by a simple, X-ray scan, whatever it was, Ralph. Now, imagine if that same system, was able to continuously monitor you for 48 hours. It would be able to tell, time. It's like, hey, we just threw up, 8, 9, 10, 100 alerts in the past, 1 hour. It's time for a doctor to come in and take a look and, double check it. People would know immediately, and doctors would be able to treat those who, kind of, it's not, check out this patient, check out that patient. It's be able to get to the people you need to get to as fast as you can. And of course that goes into medical savings, that goes into better survival rates, that goes into just happier society. Ralph, this is the kind of stuff I love hearing, from our segments. So great story.
And I just, not to labor the point too much, but I just thought of another idea. I love medical shows like Chicago Med and so forth about the ERs, right? Emergency. Well, what if the field ambulance medics could slap one of these stickers on a incoming patient, and the receiving ER doctors are able to look at an ultrasound, high-res ultrasound of a wound location, or I don't know. Just think of the possibilities. There's another possibility that could be really compelling, potentially. Right, well, I would hope. And
last then one. Military for sure. Field medics and that kind of thing would definitely love it as well. And of course, natural disasters where you can't get full-blown machines out. Last one, and then we'll move on to story number 4. But I just thought of one. Ralph, what happens when all of those images are connected to an app that, you go to the drugstore, you buy one of these things, you download the app, you connect it, it's able to transmit the data to your phone. Anyone who needs one of these, maybe for pregnancy concerns, like you just said, or maybe for heart murmurs and whatnot, go to the store, pick up a patch, slap it on yourself, download the app, and hey, you avoid the hospital altogether. You can check it out yourself.
Yeah, that's interesting. The article was inferring medically controlled and dispensed, but who knows what that future could be? It could be that. For example, especially for pregnancies, that could be a really interesting thing for the expecting mother to be able to have a little sticker that they could go to the pharmacy and purchase and get the app on the phone. And, it could be, even if it's just for the fun of watching the little guy grow, right? I mean, it could be sort of entertainment.
Right. Yeah. And all this stuff is very far down the road. But hey, the fact that we see the possibility is the first step to making it possible. So there you go. Story number 3, a lot of implication of that. Story number 4, let's go ahead and talk about this one. And this one, I think I actually did see on the mainstream news. So I'm sure, if I did, then a lot of other people that are much more in tune did as well. But you want to talk about implications. This one could get a little political. We're obviously, and Ralph and I never really do on our show, but medically speaking, this is, this was a big, kind of head scratcher about what is what really constitutes life. So story number 4.
Well, yeah, that's a very good point. And let's get the headline so people can understand why we're, framing it in this sort of potentially controversial and for some people troubling, for other people fascinating. It's got it all going on. And you're right. This was picked up by the mainstream press because of its profound implications. So headline here is: scientists have created a synthetic mouse embryo with a brain and beating heart. And when I showed this story to my wife, she immediately said, wait a minute, time out. But let's go on here. I got this from Newsweek and then, of course, picked up by many, many, many other news services as well. So after 10 years of work, researchers at Cambridge University in the United Kingdom recently announced that they created a synthetic mouse embryo with a brain and beating heart. It features the foundations of all the body's organs, including, neural and gut tubes that protect the developing spine and intestines. And if you want to do a little research, gut tubes are interesting. The team of researchers developed the embryo model without eggs or sperm. Ding, 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 ding. This is really interesting. Instead, they used good old stem cells. We've all heard about stem cells. The stem cells are the body's master raw materials. This is the most simplistic way to describe it, which can develop into almost any cell type in the body. So here's a little more on how they did this. The researchers, and by the way, this is a good example of where if you really want to get into this, you need to read this article and other articles that are in the show notes, because we're giving you the really, really high brush over the surface of the water key points. The researchers mimicked natural processes in the lab by guiding 3 types of stem cells found in early mammalian development to the point where they start interacting. So they're talking about very early after conception. Inducing the expression of a particular set of genes and establishing a unique environment got them to talk to each other, got them to communicate with each other. Again, this is such intense science. It's a little difficult to even try to gloss over it. Right. The synthetic mouse embryo model copies the stages of natural mouse embryo development that take place up to 8.5 days after fertilization. So they mimicked what's going on in a short period of time after fertilization. So the synthetic mouse embryo, this part gets really weird. And this is the part that got my wife going, wait a minute. So the synthetic mouse embryo, brain, beating heart, even started to grow and develop muscles, a gut, and a nervous system, all of which are helping to shed light on how tissues form and the causes of genetic diseases. And this is where my wife went, wait a minute. Is this little embryo going to ultimately grow into a viable, real deal mouse? And none of the articles I looked at, maybe you'll find some, Ben, but I didn't find any that really addressed that question. Are they going to cease the development on purpose after they have attained the information they want from this synthetic embryo? Is it a life? Is it a viable life in its own right? With, for some people, religious implications and other people ethical. What is this thing? That wasn't addressed very much in a way, although there are some talks about how this development puts into play what we're alluding to. What is the definition of life? Is this a living thing in the sense that we understand a living thing to be, or something else? Right. That alone is like, just takes your brain and goes, but anyway.
Oh yeah, so, and just reading a little bit of the article, or at least this article from SciTech Daily that you linked.
Right.
The problem, like right now we're doing mice, and that's very important because mice are a great test subject, but also if you wanted to translate this to human and people and babies and embryos, Ralph, you're in some places you're not allowed to touch human babies because they're that's human embryos anyways.
Right.
You're not allowed to even touch that kind of research. And in other countries, like in the UK, for instance, they say here you're allowed to test up to the 14th day of development. So only like the first 2 weeks of an embryo getting fertilized. It's furthering this research is going to be tricky, but so far mice,
Yeah. And again, to recap or to re-stress again, the point the Cambridge team says, we're doing this because we want to shed light on how tissues form and the causes of genetic diseases. So their motivation is noble. It's just how you're getting there that's problematic for some folks. So according to the Cambridge University team, the results of their research could help scientists understand, and this is really key, why some embryos fail while others go on to develop into healthy pregnancies. But that's a noble goal. In addition, the results could be used, and this is another profound possibility, the results could be used to guide the repair and development of synthetic human organs for transplantation, another noble purpose for this. And finally, another benefit of this breakthrough is that it could also potentially reduce the use of animals for medical research and experiments, which of course the animal rights and folks would care deeply about. And according to the lead scientist on the team, and I did an extracted quote, you'll see my little ellipses and so forth, indicating there were other words in there that I removed because they were a little too geeky or so on. But according to the lead scientist on the team, the stem cell embryo model is important because it gives us accessibility to manipulate genes to understand their developmental roles. And again, the developmental roles of these genes at the very early stages of, 8 days after conception.
Right.
So, wow, this is a really thought-provoking article in development and one to watch. And it's just, it's just absolutely, I'm just jaw-dropping awestruck.
Yeah, and so for it seems like the scientists were doing this, because she kind of mentioned that first of all, this stage of the embryo is normally not accessible. This is inside of a mother, and this is something completely hidden to us until this moment.
Right,
Ralph, I don't see anywhere that this could possibly develop into a fully functioning like mouse, for instance, because it's completely outside of a womb and they can keep it alive for a certain amount of time, but then it would lose nutrients and just wouldn't have the support structures.
That makes sense
to kind of keep it going. So unfortunately, no weird, parentless. What was that show? It was like Kyle XY, like the kid born without without a belly button. That's not going to happen anytime soon. But I will say, just skimming the article, Ralph, they were making a point that we often talk about here on the show as well. This research is very important for not just developing babies and embryos, seeing how they kind of fail and which ones succeed, but also growing human organs ourselves and being able to transplant lungs, hearts, kidneys, whatever. Ralph, this is important research to growing human organs for transplant in people who need them, and that is a great effort. So much work is being done, Ben, to your point, here and so many other stories we've done in this worldwide effort to avoid having to put people on wait lists for donor organs. That's the key. Yep. You definitely don't want to, genetically altering pigs is going to be a big one. Growing them ourselves is going to be a big one. 3D printing them is going to be a big one. And hey, now we don't have to wait. We can proactively help people on our own timeline. So, Ralph, with that being said, great stories all around. Once again, everyone, computeramerica.com if you want to find those. And of course, Ralph Bond Wicks, if you want to search that, you can find his site. But everyone, thank you so much for tuning into the program. We'll catch you here next time. Everyone, have a good one. Bye-bye.